What would your life be like if you had a severe cough, congestion, and clogged up airways your whole life? And even a cold could be life-threatening. Over 30,000 people in the U.S. alone have the genetic disease cystic fibrosis. Today we're going to talk more about this genetic disease.
Cystic fibrosis is a recessive genetic disease caused by a mutation in the CFTR gene, the cystic fibrosis transmembrane conductance regulator. And basically what the CFTR gene does is it regulates the transport of chloride ions between the cells that create mucus, saliva, and digestive enzymes. So people with cystic fibrosis, because of the mutation in the CFTR gene, their body doesn't regulate the transport of ions between these cells, and so they get thick, sticky mucus coating their lungs and their pancreas, making it hard to breathe or to digest any food.
These are the breathing treatments that people with CF have to do daily. They have to sit while the vest shakes them to loosen the mucus in their airways so they can try and cough some up. They also use aerosols, which is medicine inhaled directly into the lungs.
Today we're going to interview my Aunt Jen. She was born in 1983 with cystic fibrosis. Her life expectancy was 11 years old, and at 16 she needed a lung transplant to survive. Now she is 32 and has agreed to share with us what it's been like to live with cystic fibrosis. Okay, what was your life like as a teen? Like, how did the disease affect you as a teen?
It affected every aspect of my life. At first, like growing up, I was pretty healthy with the disease. It affects everyone differently. And then by the time I was a freshman in high school, I couldn't go to all my classes. I had to sleep in just because my body was so drained from infection. And then every morning I would spend 2 to 3 hours doing aerosols and other breathing treatments. And then the disease progressed to the point where my my junior year of high school, I was only going to 2 classes my first semester. And the second semester, I was at home all the time on oxygen and virtually bedridden because I was so ill and was coughing constantly and basically dying. Pancreas creates digestive enzymes, and the mucus in my pancreas blocks the enzymes from being released, so I can't naturally digest food on my own. So instead I take pills that are enzymes, so that helps me digest the food. And then also my doctor said, you know, if you're lucky to live long enough with CF, you'll get diabetes, because again, that's another function of the pancreas. So I got diabetes when I was 20, and so I have that as well.
Have there been any good things that came from having this disease?
Oh, definitely. I think the number one thing was just to appreciate life. You know, growing up, I always knew that cystic fibrosis was the #1 killer of adults, young adults. And knowing that growing up, it kind of changed your perspective on everything. And I think that was a really good thing, because I grew up, you know, not caring about being popular or silly things like that, because I knew that, oh boy, here it comes. I knew it was only a matter of time, you know, that I potentially could die. So I think it was really very good in that way, because not many people go through life with that sort of appreciation. And I think it also, made me very grateful for my parents, who sacrificed so much for me, because they were the ones starting and stopping my IVs, like when I was really sick, and doing so much for us. And so I think it was really good in developing I guess a feeling of gratitude, which to me, if you're only as happy as you're grateful. And so I felt like I was happy.
In the process of protein synthesis, the DNA from the nucleus is transcribed and the mRNA attaches to a ribosome. The rRNA is made up of nucleotides. 3 nucleotides is a codon. So the tRNA goes, and an anticodon pairs up with the codon, dropping off an amino acid. So what happens is this creates a long amino acid chain. However, people with cystic fibrosis are missing 3 nucleotides. And so when the anticodon goes to pair up with the codon, it has nothing to pair up to. So an amino acid is missing, creating a mutation in the protein chain. Because of the mutation in the protein chain, it creates a mutation in the protein channels between the cells that create mucus, saliva, and digestive enzymes. The CFTR gene creates the genetic makeup for making the CFTR protein channel. This protein channel transports chloride ions in epithelial cells, meaning cells that produce saliva, digestive enzymes, mucus. And so what happens if you don't have cystic fibrosis is the protein channel can regulate the transportation of chloride ions, and so you have thin mucus that just keeps out the germs. But what happens if you have cystic fibrosis is your CFTR gene, it creates a malfunctioning protein channel, and so it can't regulate the transportation of ions through the protein channel, creating a thick, sticky mucus on the inside of the cell, making it hard to breathe or digest food. Cystic fibrosis is a recessive genetic disease that causes a mutation in the CFTR gene. So basically, if one parent is a carrier and the other parent is a carrier and they have kids, there's a 25% chance that one kid will have cystic fibrosis, and there's a 50% chance that both kids will be carriers, and there's a 25% chance that one kid will not be a carrier or have cystic fibrosis.
Cystic fibrosis was thought impossible to cure until a breakthrough occurred in 2012. Scientists from Vertex Pharmaceuticals discovered Kalydeco, a drug that treated CF to the genetic level instead of just the symptoms. This drug affected 4% of the CF patients with that certain mutation. A treatment called Orkambi was released this year on May 12th. It is taken with Kalydeco to help the protein get to the cell wall so it can do its job and improve lung function. It will improve the lives of over half the people with CF